All right, we're Kobe and Grace, and today we are going to be discussing how to solve a nodal analysis problem that includes dependent sources. For this circuit, we have an independent current source on the left, 3 resistors, and a dependent current source.
So we're going to start our nodal analysis by first labeling our V1 and V2 nodes, and then we're going to ground the circuit. The next thing we're going to do is write our KCL equations for each of these nodes. So first we're going to write the KCL at V1. Okay, so starting from V1, we're going to look at each adjacent node and write, for this case, 3 separate components to the KCL equation. So first, from V1 to V2, we have that flowing over a 1 ohm resistor. So that's what that's going to look like. And then next we're going to look at V1 to ground. So that is going to be V1 minus 0 technically over a 2 ohm resistor right here. And then the last branch that we can look at is V1 circling back to ground. But we're just going to be looking at the current source right here. Since current's flowing this way and we're looking at V1 to ground, it's going to be a negative 3A. And that equals 0. Okay, so it's going to be a similar concept for the node V2. We're just going to look at the adjacent branches. So first we'll do V2 to V1. It's similar to this one up here because it's still flowing over the 1 ohm resistor. It's just backwards, of course, because we're going the other way. And the next branch we'll do is V2 to ground. Similar to this component of the KCL equation for V1, this one's just going to be plus 3Ix because we're flowing from V2 to ground and the current's flowing this way. So that's why it's going to be plus 3Ix. And the last component is V2 to ground, and that's just going to be V2 over 3 because it's just going straight to ground, which would technically be 0, and it's flowing over a 3 ohm resistor. So yeah. Okay, so now we're going to be doing the algebra to solve for V1 and V2 in both of these. So I'm just going to put a little star so that you can follow my work, but we're going to go over here and solve the algebra for V1. So we're going to multiply the equation by 2 first. So we're going to have 2V1, V2 plus just V1 equals 6A because we move that over after we multiply it by 2. And then it's just going to be algebra from here. So that is what V1 will be equal to, and now we need to do the algebra for the node at V2 so that we can continue with our systems of equations here. Okay, so now we're going to start solving the algebra for the KCL at V2 equation, and we're going to start by multiplying this whole thing by 3 to get rid of this one on the bottom. So we're going to have 3V2 minus V1 plus 9Ix plus just V2 equals 0. We're going to multiply it out. So now since we're going to be solving for just V1 and V2, we need to do something about this Ix over here. So we do have one law that can help us with this, and it's Ohm's law, which is V equals IR. So we're going to use that to get a value to put in for Ix here. Since we're referencing this component of the circuit right here, we're going to be dealing with V1 and 2 ohms right over here. So that means that Ix is equal to V1 over 2. Since we don't know V1 yet, we're just going to plug this in right here for Ix. So we now have 4V2 minus 3V1 equals negative 9 times V1 over 2. And now we're going to solve this out a little bit more. Okay, we're just going to carry the work up here so it doesn't get cut off, but we have plus 3vi. Now we're going to divide both sides by 4 so that we can get our v2. So it's going to be negative 3/8 v1. Okay, so now that we have what v2 is equal to, we're going to put it all the way back over here in for v2. Okay, so we moved the Ohm's law up so that we have more workspace to finish this problem, but v2 is equal to negative 3/8 v1, and then we're going to be plugging that into this equation over here. So I'm just going to write that up here. 2, 3. Okay, so now we've substituted this value in for v2 into the equation from v1, and we're just going to do algebra to get what v1 is equal to so we can plug it back into up here. So we have v1 equals 2 plus, just going to do that, negative 3/12 v1. This is going to be 15/12 v1 equals 2. We're just going to divide this side by 15 over 12. Okay, so that will result in a decimal value of 1.6. That'll just make it easier whenever you plug it back in up there. So now we have v1 is equal to that. Just going to bring this all the way up here. And now we have Ix is equal to 1.6 over 2, which is equal to 0.8 amps. And that is our answer for Ix, which was what we were initially trying to find in the problem.